All right, so we talked about the tick marks mean that the sides are congruent in these triangles. They gave us 3 sides that are congruent in each triangle. So this is SSS, or side, side, side. We can say that these 2 triangles are congruent to each other because we have 3 pairs of corresponding congruent sides. So if we're starting with triangle ABC, we need to name the next triangle in the same order as ABC. Let's start with triangle. Remember that little squiggly with an equal sign means congruent. If I'm starting at A and going to B, I'm traveling along the side that has 2 tick marks on it. And then if I'm going from B to C, I'm going along the side that has 1 tick mark on it. So that's the same order that I want to go in for the next triangle. How would I do that? X to Y is 2 tick marks, and then to Z is 1 tick mark, so that's correct. X, Y, and Z. Make sure you name it the same way. That's super, super important, in the same order. For B, or for number 2, they gave us 1 tick mark here. And then what's the next thing they gave us? So we have 1 tick mark on AC and 1 tick mark, my highlighters are going crazy again. 1 tick mark on FD, right? And then what's the next thing you bump into if you're walking along the sides of this triangle? The angle, right? So the angle, there's an angle marked at A, and then there's an angle marked at D, okay? And then what's the next thing you bump into if you're walking along this triangle? The 2 tick marks, which indicates what? That tells me that those 2 sides are congruent, right? So we started with the 1 tick mark, which means AC, the side, is congruent to FD. And then we did the angle A, and then we jumped to the side, yes? So this is side, angle, side. It goes in order. So for this one, we've got side, angle, side. The angle for side, angle, side has to be between the 2 sides. So you can't skip over an angle and get to the next angle to get there. So like, for example, if I had something that looked like this and I had side, I can't skip over this angle and then go like over here and say this one. Okay, and then maybe do this one. Hey, what would this be? Angle, side, side, and remember that's not a thing, right? Yeah, remember from the video yesterday. So you can't skip over the angle if you're going to do side, angle, side. It has to be the next angle from that side. You can't skip over any parts. And we start with C and go to A. So C to A is the 1 tick mark side, and then we're going to B, which is 2 tick mark side. So how could I name the next triangle? F to D to E, correct. Make sure you put triangle F, D, E. What questions do we have? So number 3, let's start with, what do you want to start with? What marking do you want to start with? Oh yeah, angle C. So we've got angle C, and then the other angle would be what? The other angle that's congruent to C. F. Okay, so C and F are congruent. Okay, what's the next thing I bump into if I walk along the edge of this triangle? That line. What does that line mean? What's congruent? AC and DF are congruent. Okay, cool. And then what's the next thing you bump into? The 2 what? The 2 arcs on that angle. Angle A is congruent to what? Angle D. And so in order, we started with angle C, and then we had the side, and then we had the angle A. So what is this called? Angle, side, angle. We got an angle, then a side, then an angle. And they're right after one another. So they're directly, like it's boom, 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 right after one another. So if I gave you BCA, we need to go B to C, and then to A. So we're traveling to the 1 arc, and then we're traveling along the side that's congruent. So how could I name the other one? E to F, and then to D. So triangle E, F, D. What did you start with in number 4? The what? Angle C? Okay. Angle C is congruent to what? Angle what? F, because they're the same size. Okay. So we got an angle there. What else do we have? Which one? A and what? A and D, okay. And then what? B, oh, B and E, those are the same size. Okay, so what theorem would we call this? Angle, angle, angle. Angle, angle, angle. Are these the same size, though? What did we do to the first triangle to get the second triangle? And we what? Scaled it, dilated it. Yeah. Does dilation preserve shape and size? It preserves the shape, but not the size. And to be congruent, don't you have to preserve shape and size? So is this congruent? No. What are these? Did we listen to this yesterday? They're not congruent. But they do have a relationship. What? Yeah, they're similar. So the little squiggle, let's, so that we don't get confused, let's write triangle CBA is similar, which is that little squiggle, to triangle. If I'm going to start with C, which angle was congruent to C? F, so I got to start with F. And then if I did B, which one's congruent to B? E. And then which one's congruent to A? D. So F, E, D. Remember that little squiggle, we learned this on yesterday's video. This means is similar to. Similar means they're the same shape. They're not necessarily the same size. Questions on that one? So mark the given triangles to show that they are congruent by the given theorem. For the first one, we have angle, angle, side. So we got to mark an angle as congruent. How do I do that? Okay, yes. More specifically, how do I mark an angle as congruent? A tick on what? That would be a side. I gotta mark an angle as congruent. The little arc. Okay, so let's do the bottom left. Let's mark those as congruent. So that's my first angle. So if we're confused, my first angle here is my arc that's here. So first angle, I've got an arc here and an arc here. Directly after that, I need to mark another angle as congruent. Well, how would I do that? Got to do another angle means I've got to do another arc, but this time I have to use two because they're different. Do we want to do the top right or the bottom right? Top right, okay. Double arc, and that's because we have an angle after the angle. So that's got to be angle here and angle here. Now be careful with this next one. If I have a side next, tell me why it can't go there. That would be angle, side, angle. So I've got to make sure that I do angle, angle, and then the next side. So it can't go down here, because then that's, well, yeah, technically it could. Angle, angle, side. It could go down there, or it could go angle, angle, side up here. Which one do you want to do? Up there? Okay. One tick mark here, one tick mark here, and that's because of this side. It could go on the bottom if you wanted it to, because both of those would be angle, angle, side. Either way, but there we are. Questions on that? Hypotenuse leg only happens with what? Somebody said it. No. Hypotenuse leg, what's the only triangle that has a hypotenuse? Right triangles. So right triangles only. Hey, where's your right angle? They didn't give you a right angle. Where would it be? At the very middle on the bottom. So angle Z is probably that right angle right there. So name the hypotenuse for the left side triangle. W. So between W and X, that's your hypotenuse. So for hypotenuse leg, you have to mark your hypotenuse as congruent. What's the other hypotenuse? X and Y. So that's the hypotenuse part of hypotenuse leg. So I've got hypotenuse here. This is a hypotenuse, and this is a hypotenuse because they are opposite of your right angle. Your hypotenuse is always opposite of your right angle. Now tell me a leg that's congruent. Ooh, this one's good. So we could do either leg in this case. Really sneaky. Tell me a leg that would be congruent to itself. leg means 2 letters. X and Z. So this one is actually congruent to itself. And I think we can handle a little preview of what we'll be learning. This one, let's say segment XZ is congruent to segment XZ. So it's congruent to itself by reflexive property. What does reflexive sound like? Reflection. And if you look at your reflection, you are looking at yourself, right? So if something's congruent to itself, it's reflexive property because it's looking at itself. That's a little preview of something that we'll be doing next week, but we can talk about it early. So we've got the hypotenuse, which is in green, and then we've got one of the legs, XZ, in pink. You could have labeled the bottom legs if you wanted to, as long as it's the hypotenuse, and then one of your legs, that's hypotenuse leg. Questions? What is this never called? Don't say the acronym, say the words. This is never angle side side. ASS. You get that from the video yesterday? Yeah. So if you find yourself writing ASS or SSA on your paper, stop yourself, because Miss B don't want to see that on your paper, and that should be a red flag of like, oh, this isn't actually a thing. What do I need to call it? And it's going to be called hypotenuse leg as long as it's a right triangle. What questions do we have? Nice. We got some time to work today. Let's look at your practice, and then day 1, number 5. We forgot to finish that one. I think I said see how far you can get.
You told us to do
D, E. Didn't I give you F?
Yeah.
No.
Yes.
Mid-segment?
I think so.
What'd you find for point D? This is day 1, number 5. 2, 4. And then what'd you find for point E? 3/2 and 1/2. So on your graph, D should be here, and E was here. You're just finding the middle of each side, and you're supposed to connect it with a line segment. That is called your mid-segment because you're connecting the midpoint of each side and making a segment out of it. So middle segment, mid-segment. If I were to draw a right triangle with that to find DE, it'd be a really skinny triangle. How long would that bottom piece be? 1/2. So this is kind of a blown up version of my little bitty triangle. This is 1/2. This is E. This is D. This is my right angle. How long is the vertical side? This side. Is what? 3.5. What 2 numbers do you divide to get 3.5? What 2 numbers do we divide to get 3.5? Well, I don't know. You could probably use a calculator on that. 3.5. What do you divide to get 3.5? I'm not telling you this. 7/2. So when you find DE, you have to use 1/2 and 7/2. There's a reason we're using fractions. Do you know what 3.5 squared is? That's why we're using fractions. So for DE, you should have 1/2 squared plus 7/2 squared is equal to DE squared. When you square a fraction, you square the top and square the bottom. So what's 1/2 squared? 1 what? 1/4 plus what's 7/2 squared? 49/4. And that's equal to DE squared. When you add fractions, you add the numerators, but you don't add the denominators. They stay fourths. So this would be 50/4. And how do I get DE by itself? Square root both sides. Make sure your square root is long, it's tall, and it goes over your whole fraction on the left side. And of course, the square root and the square undo each other. So I've got DE is equal to, what's the largest perfect square factor of 50? 2 times 25. Which one do you know the square root of? 25. The square root of 25 is 5. That comes outside. What stays under the square root? 2. And then on the bottom, you're also taking the square root of the bottom. So when you square a fraction, you square the top and the bottom. When you square root a fraction, you square root the top and you square root the bottom. So what's the square root of 4? 2. Tell me why I can't divide 2 and 2 here. 2 on the top is under a square root, 2 on the bottom is not. So the square root of 2 is irrational, 2 is rational. We don't divide those. So you don't mess with anything under a square root unless you can simplify it. This is where it stays, and of course I should have put units. 5 over 2 square root of 2 is also the same thing, but you won't see that very often. You'll see the one that I boxed very often, especially when we start trig. And then which segment is parallel to DE? AB. That's a property of midsegments. They are parallel to one of the sides of your triangle, whichever side it does not meet, it's parallel to. Notice, what's the relationship between DE? What'd you get for AB up here? What was AB? 5 square root of 2. What did I do to AB to get DE? If AB was 5 square root of 2, how did I get DE? What did I do to 5 square root of 2? Divided by 2. That's another property of your midsegment. So, important note here. Midsegment equals half of the parallel side. So if it's parallel to AB, its length is going to be half of AB. That makes sense because we met the other two sides in like halfway between, like in middle. So we kind of cut them in half. Makes sense that it would be half the length of the parallel side. Questions on that? I wanted to make sure we talked about that because I think second got the chance to, but we didn't. All right, you've got about 9 minutes to work now. Day 3 practice is what's up next. Let me know if you have questions. This is a great time to ask me homework questions. Ask me questions on the aims if you had them. Maybe knock out a couple Math Excel problems. Your Math Excel is due tomorrow night. Maybe knock out a couple of those.